Right, hello again, 3 days in a row. So, welcome back to another CRT live stream. Today we're taking a look again at the Prusa i3 Mark III, of course, and it is built, it is fixed, hopefully, and it should be pretty much ready to print. So today pretty much all we're going to do is trying to get a first print off it. I wouldn't be surprised if we have some little problems, so there will be some little things to go over, I expect, but that's the plan. To do the things with the printing and make the little boat called Benchy. Well, I don't have to do Benchy, but I've prepared a couple of files to print a Benchy, so that will be the plan. So, of course, let's cover the issue. I am sure I'll get people coming in at other times in the stream to go through what the issue was. So, but let's explain it now anyway. Let's just switch over to here. So, this fan, obviously very important. When I plugged mine in, I had mine switched over. So, as a result, not only the hot end got hot, but the cold end also got hot. As a result of the cold end getting hot, the filament expands. So if you didn't know, the plastic as it comes down at 1.75 mil, before it gets into the nozzle, it expands up to more than 1.75 mil. I'm not sure exactly what it is, but it expands quite significantly. So that's why it's important to have a short transition zone where you go from the thin, solid material to the full size, to the fully molten. And it's not fully molten, but you know what I mean, the soft printable material. So essentially what's happened is, well, this. Because of that hot end, the cold end getting warm, the filament expanded basically halfway down the heatsink. I've got a piece of PTFE tube here to give you an example, because it is a PTFE lined hot end. And there you can see it doesn't really, so it barely fits on there. I found it like that. And that little lip was basically jammed up against there. So it obviously expanded into that little gap. And as it cooled, I could no longer pull it out because it was obviously this way up. And you can't pull that way, the plastic rim's in the way. So I basically had to disassemble this fan, half of this fan, that front panel, most of the cables to get enough cable length to get the whole hot end out. And then I could pull the PTFE up and out in order to get the plastic out the bottom. So, quite a big issue, but mostly my fault. It is a little bit strange that the printer doesn't ask if you've assembled the hot end fans right. It just assumes that as long as they're spinning that it's correct, which is not ideal. So hopefully they'll improve that. But for me, not a major issue. Quick bit of disassembly and I'm there. I also, in the meantime, because I put my filament sensor thingy around the wrong way, well, not the filament sensor, the cable. The connectors, there has two connectors, one up here obviously and one down the other end. They are slightly different and I assumed that they were the other way around and they weren't, so I swapped them around back to where I believe they should be, and now they are correct. So, this is just a proof that I haven't printed anything. I've obviously done the little calibration stuff, the little zigzags to hopefully get my Z height just right. I have noticed already actually that it's not flat, certainly not flat. This side of the print bed gets a lot closer than this side, so this side's pretty high, this side's pretty low. No, the other way, this side's high, this side's low, so the print is further away. Hello Tom, good to see you again. So as a result of that, you tend to get not so much sticking on this side, so I'm going to probably have to fiddle with the calibration to do that. I'm not sure quite why the mesh bed leveling doesn't adjust for that for you. It seems a bit odd to me. But whatever, I thought that was the point of mesh bed leveling, but we'll see. Maybe it'll do that anyway, but that's what I noticed from doing the live Z adjust testing at the beginning. So we've done quite a lot of talking. Let's go and do a preheat to get this up to temperature. I've got some files on this SD card. So what I've got is one from Prusa Control and one from Slick3R, or Slicer, depending on how you like to say it. Slick3R I think is technically correct, but it sounds ridiculous. They're loaded on the SD card, so it is an SD card print I'm going to be doing today, rather than anything Octoprint or Repetier host or anything like that, Repetier server. Just going to go basic SD card print. I have noticed also that the heat up time is pretty slow, so probably should have got this kicked off a little bit sooner. But yeah, that 30 degrees, once you get up to 35, it just really starts to chug a bit. Your fan was also brown! That's unfortunate. I'm sorry to hear that. Although it makes me feel a little bit better, I suppose. Well, I think we've already covered, for anyone that wasn't here, that the brown fan rather is obviously better because it motivates the air to go faster and gives you better cooling. This is obviously entirely scientifically correct, and there's no grounds to argue with that. It's obviously entirely scientifically accurate. Is the Z adjust an overall adjust or at each of the mesh points? So the live Z adjust, I believe, is a global Z height adjustment. It means you can basically do that calibration in one print. It just basically draws a line and you can wiggle the thing and it goes up and down and you get the right height. It's not perfect because obviously it doesn't seem to, when it does that, a calibration print, it doesn't seem to adjust properly for any other data. Even if you do mesh bed leveling and stuff as well, it still doesn't seem to account for it. Fan is a total understatement. It looks shitty, but it's not. Yeah, it's a really good fan. If you're into the old computer hardware and stuff, you'll already be aware of Noctua fans. They are pretty much the best fans going. Super reliable, made by proper engineering nerds that clearly know their stuff. They spend quite certainly a lot of money on analysis and design work. Probably mostly analysis to make sure that their fluids flow is optimal. Good afternoon, Dark Orbs, good to see you. So yeah, Noctuas are pretty much as good as they get. As far as I can tell, they spend pretty much no money on marketing and they just try and make the best product they can and they sell it at the price that they need to. So they're quite expensive, but if you want the best, you pay for the best. And I don't think that is ridiculous at all. So we're heated up. Which way up does this go? That's the way. Card inserted. So I believe I now pretty much just go print from SD and find the one I'm looking for. So there's the Slick3R or the PLA Optimal, which is from what's the Prusa software? Prusa Control. I think Prusa Control is not set up for the Mk3 yet. Not sure, didn't check, didn't have enough time. So I've got that file on there, but I think I might as well just go for the Slicer one because I know that that Slick3R profile is for PLA and is for the Mk3. So I guess we just press the thing. It's going to do some more heating, which is weird because it should be done. Yep, okay. It's off pretty much straight away and we're printing. The X-axis movement seems to be louder than before, as does the Y. The Z is extremely quiet. You can hear there's a bit of... Oh, push control is ready. It's in Mk3 settings. Okay, well, I didn't do that, so my settings are probably for the Mk2, so I won't bother. I don't think it's going to be a problem. I've got this and it should be fine. My only concern is it prints at the right Z height. That looks pretty good to me. it's shaking the desk, but that is pretty quiet. It's so quiet. That's insane. Did you change the default PLA bed temperature, or they changed it to 60? This is all just their complete default profiles. I didn't change anything. So yes, if their default for PLA is now 60, then it's 60. No, but way slower. Not too bothered. Yeah, it is. Well, I think, so typically on printers, people blame the bearings for the noise. And while that's probably strictly true, the noise is coming from the bearings. The reason the noise is coming from the bearings is the vibration from the stepper motors. So the vibration starts at the stepper motors, moves along the steel rods, where because of their length they vibrate more. Presumably the amplitude increases at that point where the bearings are, and it shakes all the little ball bearings inside. That would be my guess as to why. Whoa, hello. That's creepy. It's really going for it. I don't think it's even as much resonance, because resonance has to be a very specific frequency, and the number, I think if it was resonance, you'd see a very few people that have very noisy printers. But I think it's more of a majority, it's just a general vibration issue. I guess that's your Mk3 on the way then. I was pretty happy when I saw that as well. So what are we seeing close up? It looks a bit mushy to me, but I mean it's quite difficult to tell. It looks like we got a bit of over extrusion. Yeah, I've heard several people have moaned the power supply rattling. I mean, I certainly can't hear any specific rattling. It does make... So every time they move up and down, instead of a vibration sound, it makes a sort of a high-pitched, light tick. It's quite a soft tick, but it's like a... It's quite difficult to hear, but it's not bad. Yeah, I did see you could do a live Z adjust. Yeah. I mean, by the time I'd looked, I was already several layers in, so... It's ridiculously hot. It's just all mushy. I don't know what it's doing, but it's not good. I'm going to stop that there. Should I? I mean, I don't... Yeah, this is not working. Do a live Z adjust if the first layer is off. No, there is not that PSU rattling going on there. Yours seems just perfect here. Yeah, sound of the power supply does sound right. Yeah, so the live Z adjusting calibration, the stuff I have done, I did that off stream because I had... Oh gosh. It looks like the Z level is just not right. It's not moving enough. I'm just going to leave it and we'll see what the result is at the end. But I can tell you already, it's extremely mushy. I'm trying to get you in for a closer look briefly. See if we can. Let's try from the other side, where there's going to be hopefully a bit more light. You can probably see that all right. It's really, really mushy. It's all curling up around the sides and everything. Presumably they do just need to do a bit of work on their profiles. Kill the power to take a better look. Yeah, I'm going to do... I do want to do all those features, so or maybe we could just do that now. It's really weird. I don't want to do it just in case, but I guess we just pull the power. I mean, it's... Here we go. I don't want to do it. I don't know how much delay there is, but it looks... Unfortunately, my... chopped down the power. My preview of the stream is abominably bad, so... My internet's not managing to keep up with the upload and the download at the same time. So I can't really monitor a whole lot, unfortunately. The first layer was not bad. Yeah, the first layer I think was fine. We'll obviously see that at the end. Yeah, totally agree. 210 for a standard PLA is pretty toasty hot. They do seem to be... I mean, the ABS prints that I got with it did look like they were all printed too hot. They were also pretty soggy. 210 seems a bit high. It was the first layer good. Screw it. Put the power out. Recovering print. The parts that come with the kit are printed in PETG. Are you sure? Maybe the black parts are ABS and the... Are you sure they're PETG? I could have sworn they printed all their stuff in ABS. In fact, that makes sense, because that wouldn't have snapped like that if it was ABS, I don't think. Interesting. They didn't used to, did they? Oh God, you can see how, look how much it's moving. Yeah, it's starting to skip steps and stuff now. So it's doing the skip step problem. Yep. Okay, so I've just stopped it there because the print, because I did the power thing, yeah, it does look extremely painful. So you can see the first layer there, hopefully, maybe. First layer was alright. It's nice and smooth. Maybe a bit low perhaps. But it just seems massively over extruded. It's way too hot. So it's all just gone completely to mush. It's all curled up on the front. Come on, focus please. So that's not hugely successful. Let's first we'll get the preheat back on. Keep it warm. Yeah, this looks too close as well. Maybe there's 2 layers of that, that's why. Yeah, let's first, before I go back to Slick 3R and customize it, let's go to Prusa control and sorry. I'm going to try and add a little window into OBS so you can see what I'm doing. So, window capture. Okay, it's not perfect, I know, but hopefully it lets you see what I'm doing. Okay, file, settings, Prusa control settings, printer model, i3 Mark 3, there we go. 0.4 nozzle. Automatic placing on my, oh, you can't see that. Auto update parameters, English, okay. Okay, well that doesn't work very well, does it? Because Prusa control won't. There's no point you seeing that. Okay, you'll just have to trust what I'm doing. So let's import a benchy. 15% infill, 0.2 layers, scale to 80%. We'll generate that. So it should print it just about there. "37 minutes. Save G code. Okay. Is this the frame rate of the video or the frame rate of the capturing that Prusa control thing? Right, so I've tried Prusa control again, not because I don't know what to do with the settings, but because I want to know what their settings are exactly. I want to see how this printer performs if you don't change anything. I could obviously change the temperatures and change this and change that and do this and do that, but to me that doesn't demonstrate this printer. That demonstrates my ability to change the settings to be better. So we're going to try and focus on the settings that they provide and hopefully get a good print from that. So let's get another benchy underway. Yep, I've selected PLA, so in the printer settings there's obviously a bunch of materials available, but I've selected as Prusa PLA. They also have a generic PLA. Bloody hell, that's quick. This is much... Is it quieter? No, maybe not. So you've got that side off, this one off, that side on. Obviously that side's on, it's the cooling fan for the heat sink. That looks like a good first layer to me. So the print settings, so I'm looking in Slick 3R now, slicer, presumably the settings are the same, you'd hope so. So yeah, 215 first layer, 210, I don't think we did that, it's just stayed at 210. And then 60 for all layers for the bed. Fan speed, minimum 85%, max 100%, bridges at 100%. Disable fan for one layer, so yeah, as you can see that's now on at 100%. Print settings, layer height 0.2, first layer is 0.2, perimeters is 2, 5 solid top layers and 4 bottom solid layers. Uh, 20% infill of cubic with rectilinear pattern top and bottom. Combine infill every one layer. No support. So speed settings, perimeter is 60 millimeters per second, small perimeters is 20, external perimeters is 40, infill is 200 millimeters per second, solid infill is 200, top solid infill is 50, support material 50, bridges 30, gap infill 40, travel is 250, first layer speed is 30 millimeters a second, acceleration control, so perimeter acceleration is 800, infill is 3500, bridge is 1000, first layer 1000 and default of 1000. They have a max maximum print speed of 250 millimeters a second. They've got some multiple extruder options, line widths and other things. Yeah, I normally do my first layers really slow. Just because I basically went the complete other end of the spectrum. With Cura, it seems to have this obsession with doing these excessively fast first layers. And when it's trying to do how do I do it? So say you were doing a donut shape. Say you had a donut shape and you were trying to do the outside circle and inside circle. As it's doing that on the first layer, it would draw the inside circle and then like move across it and just flick it up because it's moving so fast. So if you slowed it, when it was slowed down, if you slowed down that first layer, it was much better. This print is looking a whole lot better than the last one. It's looking smooth and clean and pretty nice. We're nearly 10% of the way through. Which slicer do I use with Steve? I use Slick 3R slicer. I might have some settings I've put in for that. But I've tried to, not tried to, I've based them off the Mark II and the Mark IIs settings and tweaked them slightly. So with Prusa, they typically have a nice thick first layer. So when you're doing, I print a lot at 0.3 layer thickness because I'm not looking for very fine detail, but more just a fast print and sort of engineering parts. Like I print a lot of printer parts. So yeah, a nice thick first layer. It's about 200% line width, which gives you really brilliant adhesion, and also accounts for any problems with your Z-adjust. But I mean, I don't have that now because I have an inductive probe on Steve. So induction. They may well be. I don't know how early on you bought your Mark II, but you can do, I don't know if this was available, so you can do a PID temperature calibration. Not temperature, it's basically response, P, I and D values for control systems. If you know about control systems, you'll know about P, I and D. Partial, integral and differential, I believe it is, which basically control your response curve. So as it forces being cooled down by the filament being heated up, it knows the amount to heat in order to maintain the temperature. And I would guess that it's not as a result of the heater not being powerful enough or anything like that. It is just PID. And then here, I don't know if they do on the Mark II firmware, but on the Mark III firmware, they have a little option that you can go and do your PID if you want to. You don't really need to because obviously all their hardware is the same, so they've probably done it on 50 different printers, put in an average and found that that is a good value, good set of values that work on every printer. And they'll have put those in and that would be good enough. I must say, that print is looking pretty impressive at the moment compared to this piece of shit which I printed for the first time, which was absolutely terrible. So yeah, I'll probably just use Prusa Control for now, especially for these live streams, because it means I don't have to tinker with anything. I just stick it in and be done with it. Let's give you a closer look and so you can see how we're getting on compared to the last one. Sorry, just got to get this wire. There we go. Sorry, I probably can't hold it very still. Doing my best. I was not expecting to like this because I was so looking forward to the nice black one. Not that the fact that it's black is significant, but it was the powder coated PEI, and I was really looking forward to using that. But the fact that this one's gold just is awesome. Did you update Steve with Marlin Linear Advance? No, I have not done that. I may do, I may not. Well, after I've done these Prusa projects and the sort of hustle and bustle about the Prusa i3 has simmered down a bit, I'm thinking I'll probably go back to doing more with Steve, release maybe another, like a version 1.5, update some of the printed parts, because I've got newer version parts on mine than I have published online. But it's so much effort for me to go through and not only upload the new parts, but upload any changes to the bill of materials, to the drawings, make a video about it. It's a lot of work to get all that stuff up to date, and then if I make a mistake on a video about the bomb or something, then it just, you know, it's just a pain. So when I do that, I want to do it like all in one go, and I can get it out of the way. But yeah, there will be stuff coming, and I'll probably update the linear advanced items. The linear advanced, I'm pretty sure it's just a single A value or K value, whatever they call it. Yes, this print is looking so much better. I could go get one of the ones from Steve, but oh well, there's one right here. This was a bit of a rush, so it's not the best quality. There were some problems with the cooling specifically. You can see up here, it sort of curls up a bit. But I don't think it's too bad. I've had worse prints. The problem I keep getting is these gaps in here. I've really no idea. Oopsie daisy. No idea where they come from. Like, it's difficult to point now. In this edge up here, I get these little gaps and I really don't know where they're from. Yeah, this is a bit of a rubbish print actually, this one. It's all a little bit hot and droopy. But that was one of the ones I did like 6 doing different various calibration things. Oh, the mathematics behind linear advance and why you need to... The explanation I did on Core XY with the actual proper maths in it is probably my most consistently viewed video. It gets probably around, well, it's not that many views really in comparison to other channels, but for me it's about 100 views every 48 hours consistently ever since I uploaded it. Right, I obviously had a little peak at the start, and then it's just been about 100 views consistently every 48 hours. Pretty much non-stop. No matter what I do, it's just, no matter what happens, always just about 100. Might go down to 95, sometimes up to 150 and stays around there for a bit. But yeah, I didn't expect it to be that popular. I was like, no one's going to want to look at maths for a few minutes about Core XY of such a specific topic, but it would appear people do quite like it. Now, just so anyone's aware, now is a good time to ask questions and whatnot. Obviously, I'm not doing anything other than sitting here watching this, so if you want to ask something about anything I do on the channel, then now is a good time. People would love to see the maths behind 3D printers. I suppose it's a lot of, well, I mean a lot of, it's basically vector maths, isn't it? Coordinate A to coordinate B, how do you do that? And then calculating acceleration and whatnot. I mean, yeah, I guess so. The problem is, well, it's not particularly a problem, but I don't think that standard printers, because they're all Cartesian motion, the motion is not complex enough to be very difficult. So, I mean, I don't think many people would wonder how it gets from here to here and how it does a diagonal. Well, obviously it does a bit of X and a bit of Y. Maybe though. I think the Linear Advance Explains video would be useful though. Have I thought about connecting the Raspberry Pi to the Rambo? Well, I don't have the Raspberry Pi Zero that's required at the moment. I mean, if it was something that I was like the first person to do and I could do a video about it and it'd be worthwhile people seeing it, then I might. In fact, I probably would. But I don't have one. It would take me some time to get one and then find out how to do it. And I don't know if it's really it's not worth it for me. But if it's worth it for others, I would probably do it. I don't know though. I've got a lot of stuff on, and that would be, yeah, so much time spent at work and not enough time making videos. It's difficult. I have to be really, I didn't think this would happen, but I have to be really stringent with videos that I make, because I get so many ideas about things that I want to make videos about, things that I think would be cool. And then I end up with a list of about 50 items, which is enough for obviously an entire year's worth of videos. But in 4 weeks' time, the ideas will change. So what of those 50 ideas am I going to make in the next 4 weeks, for example? So I have to cut out most of the ideas about videos because I just don't have time to make them. The other thing is, sorry, I'm eating these, if you're wondering why you can hear me chewing, I'm eating these Haribo dinos that came with the Mk3. I've forgotten what I was going to say. Never mind. I have interest, how many people have we got watching? Because I can't see. Oh, I know, because yesterday we ended up with like 40 people, which was pretty insane. But that was after Tom's stream. We ended up with quite a lot of people coming in from that. I don't know if his stream is still going on at the moment, but he was doing the hang printer last time I looked. $19. Cool. Well, hello to all 19. Thank you for being with me and taking a look at this printer. Good to have you here. A solid 20, thank you. Everyone just like open it on tablets and phones and everything just to make it make it look more. No, don't do that. I don't think that's a good idea. This is a bloody ridiculously good quality Benchy. Those smooth drivers just make a massive difference to them. Well, not only the noise but the vibration, so you get much cleaner print as well. It looks chuffing fantastic. Let's see if I can get you a closer look. It's ridiculous. It's so good. I think, well, I'm going to have to try and do some massive prints on this. I'm going to have to start doing things overnight, I think, because that's the only way I'm going to get enough time to print out some decent sized stuff. I do probably a vase or two, some good sized models, some engineering geometry. Oh, it's proper good quality, that print. Unless it comes unstuck before the end. Oh, the front is so let me show you that. It's lush. It's so smooth. Can you see that? Probably not. Because it's just going to focus on the stuff that's further away. What if we do this? So smooth. Yeah, if everyone wants to go ahead and like the video, I wouldn't mind that at all. If you think it's worth liking, then like it. If you think it's absolutely terrible, then I'm not sure why you're here. Do I want to pull the cable out again? It seems a shame to try and ruin such a blooming good print. But I do need to, don't I? Go on then, let's do it. It seems like such a ridiculous thing to do. Oh, this one. Well, I tried to put it on and it's sort of, well, it broke quite a lot. Sort of, I just literally tried to put it on the top, but it doesn't flex enough. The geometry's not quite right or something, and it just snapped in my hands. But that's why I mean, that's characteristic breaking of PETG. So, and yeah, you said Joseph Prusa said it was as well. So he ought to know. I'm pretty sure it is PETG. Yeah. Right, let's pull this power cable out. Oh, it didn't raise up. Or did it? It might have done. I know, I just didn't see. Recovering print. So it's lost 5 degrees out the hot end and 1 degree off the heated bed. So this time, because the print is nice and smooth and not all warped and curly and horrible, it should just be able to get that heat back up. Come on, it's still at 59 on the bed. 60 and 210, both at the same time. Here we go. I'm going to leave that bit of extra filament on there just to see what it does with it. It just Ooh. No, see, that's fucked. It's completely lost the Z position. Well, that didn't work, did it? Do I want to take the bed off? See, the thing with having a removable bed is already, it's super hot if you want to just don't really need it, I suppose, for a print that size. has very little thermal capacity, that bed. I'm just going to immediately start printing another one. Yeah, so that Z thing just didn't work at all. So, excuse me, sorry. That's heating back up again. So let's take a look at this and see what happened. Well, there was another question there. Did you contact Prusa? They're interested in feedback to improve the parts. Well, I could, but I'm not sure they'd be that interested. I'm sure they know these things already. Or maybe, well, presumably they don't if they want feedback. I could, but I'm just going to make videos and stuff about it anyway, so they can watch those if they want to know. So, just here is where I stopped the print. Come on, focus. Focus, please. Come on, focus. So just here is where I stopped the print, and you can see at that little circle, the nozzle did in fact not do what it was meant to. Oh. Oh, well, that corner stuff's all there. So yeah, where that nozzle's supposed to, with the remaining power, oh, come on. Focus, please. Focus, please. Where it's supposed to raise up away from the print, it seems to have just sunk into the print. So it completely forgot the Z position. So when it came back to doing the next part, it literally just sunk straight into the print. It's completely ruined all around the sides. You can see it's tried to print, in fact, lower than it had already printed. But, that being said, up to that point, that quality is pretty ridiculous. That is pretty exceptional. For the size of the print, there's some pretty good detail in the bottom. In the back rather, that hole's nice and shaped. The words are not really visible. The curves are extremely smooth. You can see some sort of the scaling sort of effect slightly, but not too bad. The bottom layer is pretty much perfect, nice and smooth. Unfortunately, we didn't get to the top half of the boat, so, you know, there's that. Slightly disappointing, but, you know, not the end of the world. Oh dear, what? Why are the two screws on the black top of the left Z-axis lead screw? What? The two screws, left Z-axis lead screw, two screws on the black top. These are screwed all the way down. Which other? These are down. These are all the way down. These are all the way down. Do they not look all the way down? They are definitely all the way down. So that's 2 times in a row now where that power failure mode has not worked. Which, as you say, is a little bit disappointing. Obviously, unless it works every time, then it's sort of pointless. It's a sort of feature where, I suppose, if you're going to have a power outage and there's a probability that your print is saved, it's nice, so there's that. But at the same time, are you going to guarantee the fact that a small power outage doesn't muck up a print? No. And that, in my mind, is sort of what they were selling. So for people that live in an area where they have a lot of brownouts, they might have avoided buying a printer up to this point, or discovered that they can't really print reliably. They didn't want to buy a UPS, or whatever other reason they didn't know about them. And so perhaps someone like that would buy this on the assumption that a brownout would no longer destroy their print. A new firmware this week? Okay, well, I'm sure they'll have lots of updates. PSU, I think you mean UPS. Yeah. UPS is definitely a good idea if you're in a vulnerable area. I've not opened the power case, the PSU little box, but obviously the whole point of the power shutoff is it's a loss of mains power. And so obviously all that's in a mains power cable is live neutral earth, so destroying the connection to the power supply exactly replicates the loss of power to a system. I'm not sure using the switch would be different, but I'm not going to do that on this print. I want to get a full print because I'm pretty sure the quality is going to be outstanding, and I'm now another hour away from seeing that. So if you all stick around for another hour to watch the end of this print, then I'm extremely grateful. See if I can pull up my live dashboard. No, I'm not going to. You just want me to destroy my prints. What would have been smart to do is get a good print out and then just spend prints just trying to destroy them. I think everyone wants to see a finished print now rather than just me destroying them again and again and again. We're going to have like little benchy steps. A little benchy with the first few layers, a bigger benchy with half the layers, and then a full benchy, hopefully, with the rest of the layers. This one definitely doesn't look as good as the second one, because this one was pretty much perfect all the way up, whereas this one I can see a bit of, in fact more than a bit, quite a lot of curling at the front, which is weird because that's pretty inconsistent. I'm not sure why that would happen, because it's exactly the same file. There is a lot of curling at the front. If I could do, maybe I should do a straw poll and everyone can vote whether they want me to. Here we go. It's time to vote. I haven't tried sticking ABS on the print. No, I haven't done anything other than what you've seen me do in regards to printing. I've done PLA, PLA, and a little bit more PLA. That Ron Hunt guy that's also been doing a live build has been very on top of it. Congratulations to him. Not found. Well, that's exactly what I just posted, isn't it? Well, that's a damn load of good, isn't it? The total time I spent, I think, probably is around the region of 9 hours. So my first two live streams were just shy of 5 hours, and the other one was 4.25. Well, that's a total of 9 then, isn't it? But bear in mind, obviously, one, I'm streaming, so everything takes twice as long as it needs to, because I'm chatting and looking at other things and dealing with other stuff the whole time. So I think 4 to 5 hours, if you know what you're doing, if you've built stuff before, I have, then the actual process is not difficult, it's just the time it takes to go through all the steps. Yeah, somewhere in the region of 5 hours wouldn't be unreasonable. So if you had a long evening, you could do it in one evening. The most time consuming, well, the most dull part was probably the frame, because it's literally just 32 screws. And it's the first step pretty much, so that's pretty dull start. What were the other frustrating parts? I mean, to be honest, anyone else can answer this that's watched my other 9 hours worth, because you'll have noticed where I got frustrated with things as much as I did. Some of the cables were a bit finicky. Some of the printed part quality was not that great, so there were times where the holes I had to cut them out with a knife because they weren't quite circle. Trying to put the belts into the carriage, the X carriage, was a little bit difficult because the belt is literally just long enough, so there's not a whole lot to grip. What else was there? Oh, these blooming things. These are the worst things in the world. So there's little black things at the bottom of each Z-axis. Yeah, the Z-axis dust caps. Man, they are terrible. They are literally the worst invention ever. I destroyed my hands trying to put those on. Well, one went on all right, but it was a bit stiff. But the second one, man, that was a pain. Absolutely terrible. I don't understand why they need to be so tight, or why they need to be literally on the... Why can't they just have something that just slides over and just sort of sits at the bottom? I suppose they don't want it rattling or anything, but it could just be... Instead of being a full ring with teeth in the middle, they could have it cut on one side and slightly undersized. So then the tension of the plastic keeps it touching the screw. It doesn't need to be tight, it just needs to stop it rattling. And that would save a huge amount of time and stress trying to put those horrible things on. The Y-axis seems like a walk in the park. I built the Mk3. Yeah, so if I switch to this, oh, you can't see it, it's blocked. So over there on the table, let's see if I can, no, I won't bother showing you now. In fact, why would I not? Hopefully you can see with that camera now. So yes, down there, this printer is my Mk3 replica. So I basically cloned the Mk3 almost exactly 1-to-1. Oops, sorry. So yeah, I've done that whole thing once before, and I have a Cintron which is all the same threaded rods and stuff. That was also a bit of a pain. This drill pole just keeps failing for me. We got 3 votes so far, of which I must confess, one of them was me. Click the link and do 1 back. Yeah, so I tried to. Oh yes, that's weird. Sorry, I'm just going to keep posting this link until it works properly. I wonder if I've been pasting in a link with it. Yeah, that's weird. It seems to just add something to it in the YouTube thing. Well, that's 5 votes now for a completed print, so I'm pretty sure that's what we're going to be doing. It's definitely not as good as the first print. There's some dodgy shit going on a couple of layers up. Yeah, you can sort of see it on here as well. Maybe not. Can you like that? It's difficult to get it focusing in the right place with the right light in the right orientation and everything. I grip it between my fingers like so. Can you see a slight line thing here? It's about 3 or 4 layers up. It seems to have a weird step. It's not skipping at all because, oh, I wonder if it's an elephant's foot compensation. That's probably what it is, isn't it? I wouldn't be surprised if it's an elephant's foot compensation, but it does seem to be thinner down the bottom there for no apparent reason. Oh yeah, Power Panic is the name for their feature. Power Panic is what they call cutting the thing mid-print and saving, but the saving doesn't seem to be a whole lot of saving going on. Solid bottom. Oh yeah, okay, so yeah, 4. I wonder if that's the solid bottom just contracting then. Yeah, interesting. Because on the print in here, I guess that solid bottom's just so thick that it just ends up with over extrusion. I might need to reduce the tension on the Bondtech extruder, because obviously if you slightly reduce the tension, you change effectively the rolling radius. Not the rolling radius, it's not the correct term, but the effective radius of your extruder gears. But will you do it by pulling the cord or running outside with an axe? Oh, I'm unlike... Considering the lack of an axe, I shan't be using an axe. So it would just be the standard pull the cable again, which I've done twice already. The power panic cable, yeah, the power panic cable is connected correct because it did do the power panic thing, I believe. Because it did resume the print, it just resumed it at the wrong time. So, I mean, there were elements of it that, so it did what it was meant to do, it just didn't execute it fully. So just to get this straight, you want me to finish this print, then print an axe, then go outside during the next print with a 3D printed axe and cut down a high voltage power line. Right. No? Maybe? And or shoot a rocket with a wire over the high voltage line. I think we're getting a little bit... This is the YouTube chat I know. I think we'll stick with PLA is non-conductive, but anything is conductive at a high enough voltage. 240 volts is not enough, but at the moment we have 1 vote for use the filament, do the filament sensor mid-print, so cut the filament, and 6 for seeing a completed print. If I refresh, it's still the same. So think of the views. No. I don't want to do clickbaity videos. I'm not doing that shit. Someone else can go do crazy things like that. The on-off switch may be different to pulling the plug out, but if you have to turn the power switch off for the power thing, for the power panic to work, then surely that sort of makes the whole feature completely redundant. Because the whole point is, if you have a power outage, then it can rescue itself. It's not when you accidentally turn the side off, which it probably helps with that as well. But it's designed for power outages. So even if it is different, I'm not sure. I mean, I'm pretty sure it's not going to be different, but even if it was, it wouldn't help the final result. Well, given what I've seen so far. Somehow zoom to that air blower near the tip. Poor. I don't know, can I? Not easily. Low on cable lengths, etc. I have got another. I don't like this step. They want me to use, yeah. Needle nose pliers for tightening nuts is literally the worst idea ever. That's when you need a 3D printed, well, or you just want one of these. A socket with a screwdriver attachment, so you can do sockets with a screwdriver thing. They do say that the air flows from all sides. So, well, the way we can actually, well, the way I was planning to see that is on a bencher, you obviously have this overhang area all the way around the top. So if you have a bad result like I do on 2 of the sides, then you know that you're not getting sufficient cooling from those sides. That's my theory anyway, so I'm going to stick with that. So the cooling I had on Steve for when I did this print resulted in some curling up at this edge because it didn't cool and go hard quick enough. Indeed, don't over tighten the nuts. Don't over tighten them, but we're going to give you very little way to actually control how tight you do them. because we're going to give you these silly little pliers that slip off everything, aren't parallel, so you can't grip properly. They're wrong size, so you can't even... Just... Just no. Just no. It's not the right tool for the job. I'm going to shameless plug again, and anyone who hasn't liked the video, if you're enjoying it, please give it a like. It will help quite a lot. It's quite ridiculous the amount of additional watch time and stuff I've had on my channel in the last couple of days. It has gone up astronomically, because obviously watch time is based on the number of people watching, the time that they're watching. So when you have just, even if it's only like 20 views on the video, if those 20 views were for 2 hours, then it's quite a lot of watch time. It's been quite beneficial. It's good news. And of course, if you guys enjoy it, then that's sort of the point, so that's good. I'm not getting a fidget spinner. I like fidgeting with knives and things. I do fidget a lot. But the thing about, see, I like fidgeting with actual mechanical things, because fidget spinning, you just sort of spin it and that's it. You're not... My mind is learning about the geometry of this as I'm playing with it, and how the mechanism is and where the stiff bits in it are and that sort of thing. So I normally pick up things that have some sort of functional part. I like playing with knives, but you won't play with an axe. Hypocrite. Well, there's a difference between opening and closing the blade in your hands and running outside like a crazy person and axing down a mains power cable. I mean, okay, they're close, but there are some differences in that. These are pretty terrible as well. I want to get some proper tools, because a lot of these tools, I mean, I have several pairs of pliers, but I've got just several pairs of cheap pliers. I'm way more happy having one pair that's expensive and I'll use them for 20 years than having these horrible pairs, because I don't think these grips are very nice. I don't know what everyone else thinks, but these rubbery grips, but they're not really, I don't know, they're not soft, they just sort of grind the flesh off your fingers. I'd much rather have nice quality tools and keep them forever and ever. So we're moving up towards the top of the benchy now. And things are looking good. The quality of the tools that they give you in the box are almost hilariously terrible. On the good side, chrome vanadium, if they actually are, then that's not bad. And they are magnetic, but that coating on the ending has just come off. It's good that they're magnetic, but I mean, non-ratchet screwdrivers, like, terrible. Terrible, terrible, terrible. These ones are literally just painted black on the end. I mean, I'm pretty sure those are as well. Makes it look high quality, but it's definitely not. Could almost print one for better. These are the sort of tools that I'll put in a box, and in like a dire emergency where I need to lever something open, I'll use a tool. And this will be it. This flimsy screwdriver that I don't really want to use for anything else. We're 30 minutes in, 58% complete. It's quite relaxing though, and it's quite quiet. So I've got another knife here that I can fiddle with. I'm not sure what the YouTube policy is on playing with knives, so maybe I should stop that. Just in case. Let's whip the sound meter back out. This is not calibrated by any means, but I'm sure the relative volumes are fairly accurate. Those pliers are literally the worst. I think my top tip for Prusa is get some proper tools and stop dithering around with the rubbish pliers. Nobody wants to use pliers. So it looks like the volume when I'm talking, I mean, it's like a stage talking, I'm talking quite loud. It goes up to, is it around 80 something, 82, 83, 80, 79 to 83, somewhere around there. If I put it on slow mode, it's a little bit easier to track. Slow mode is sort of like an average over time, so as I'm talking for a while, it increases, and when I stop talking, it will go back down. So there you can see it stuck around 56 when I was not talking, which is pretty quiet. It's not in silent mode, I don't think. I have no idea how to change the modes, but there you go. I'm not sure you could say they're free as such, because I paid for the kit and they were in the kit. Some price of that kit will have gone to having tools. They might say that they're free tools, but in fact they probably put a cost in the BOM for tools, so they're probably not really free. I think it's good that they provide tools, absolutely, because not everyone has the tools, especially if you're a beginner to 3D printing or even assembling. If you're quite young, you might not even have collected any tools yet. So I think it's nice that they include tools, but if you're that doesn't mean I accept that tightening nuts with pliers is good. What do you think so far of the printer? Gut feeling, are you happy with it? It's difficult really for me to say. I mean, I've used it for 10 minutes. Well, no, it's like 2 hours now. But I mean, I need to use it for a decent amount of time, see how many failed prints I get and things like that, because that's the stuff that's important to me. If I can print 20 things in a row without any of them printing, without any of them failing, or if I can cover the entire bed and just leave it for 10 hours and print lots of little things that could interrupt each other on lower quality machines, that's the sort of thing that when I think, yep, I'm happy with spending the money on this printer. So, can't really give you much more than that at the moment. I've not found anything bad yet, particularly bad. I mean, there's a couple of niggly things, but nothing majorly bad yet. How is my 3D printed spool holder? Have you managed to not break it on assembly? A lot of people keep asking about this. It's broken. Very broken. I literally just tried to attach it to the top of the frame, the same as the injection molded ones, and it just immediately snapped. It couldn't go down, it couldn't go in, so I just tried to push it, which is the only way to get it on, and yes. It's now, well, I would say it's in two pieces, but strictly speaking it's not. It's still in one piece, but it's not particularly functional. Away for 10 minutes, did you miss something? You missed the last 10 minutes of this, but other than that, I don't think anything major. What they need to get, I don't know if anyone else has built computers in the last few years, but they have things like this, where it's a socket on one end, but on the other on the other end, instead of being a square socket like that, it's a head for a screwdriver. So you put the socket on the nut that you want to tighten down, and then you can use a normal screwdriver and excuse me. Seeing as they're already supplying the screwdriver, they just need a small thing like this, which I'm sure would be pretty cheap to include. They might be able to 3D print them. That might be optimistic. But I'm sure they could do better than pliers. There's got to be something better than pliers. Anything. Something that actually fits the nut. Even if it's like a thumb tightening, it's better than that. Did you snap your spool holder as well then? Am I not the only one? I think the geometry or tolerance, excuse me, sorry. I think the geometry or the tolerances is just not quite right. I mean, I would never expect a square to fit over their square, so that phrase literally made no sense. But if you think about it geometry-wise, in order to get something in at that angle and then rotate it round, you've got to have some clearance at the top here, and there's just nothing. So it just crams up into that corner, and then this can't go down far enough. So you do that, and then the whole lot just breaks. You did snap it. Yeah. It's just not good. I don't understand why. Well, one, they should use ABS because it would stop the complete snapping. But I don't understand why they insist on this ridiculous geometry. They've got a steel frame. Why not just put some holes in the frame and just tie something to it, screw something to it? I mean, how difficult could that be? I'll tell you how difficult. It's not. All they need is something like this. Get rid of the bottom bit, put a hole in here with a nut trap on the other side. You hook the top over, or just push the top over. It has some sort of slight friction fit there, and then a screw that goes through. So the force is being held vertically by this, and it's kept in line here by a screw to stop it going forwards or backwards. Takes less plastic, a single hole in the frame, and jobs are good. And also this whole thing. This is another thing I don't like. So what we commonly refer to as a Bowden tube or Bowden tube is just basically a feed tube. And you should always use a feed tube whether you have your extruder by your hot end or not. Because by using a feed tube, you keep the distance between the spool and the hot end the same. So it's probably quite difficult to explain like this, but if you imagine from the I'm just going to do some pointing for a minute, so let's just raise this up a bit. So the distance from the, say all the filaments just coming from the centre top to this point and centre top to this point are the same, but the centre top to here is shorter. So the distance between the extruder slash hot end slash the whole assembly, the distance from that to the PLA source changes, which means this is pulling some of this filament. So as it moves across here, so at the moment obviously it's on a short distance. If this was to do a large print and move across to here, as it does that motion it would be just pulling off the spool, which is not good. By having a feed tube between here and a static place on the frame, I mean you wouldn't put it there because you'd never be able to get anywhere. You'd want it round the back, spool maybe down on the base somewhere else, or sideways at the back, or on the just side. I don't know where you'd put the spool. That's not the point. The point is there should be a feed tube that's attached to the frame so the filament can come off of that into here. So the distance between a rigid point on the frame and here, and thus the length of the filament, is always the same. Hopefully that makes a little bit of sense. It's more of an explainy type thing that should have been properly summarised in a video and constructed correctly, but I think it's important to say it should have a feed tube, otherwise known as a Bowden tube, which is not always just when you have what people commonly refer to as a Bowden setup, where you have your extruder motor separated from your hot end. Hopefully that's clear. Does anyone know why are going to PET than ABS? I don't know. I'm a bit upset that these are PETG and not ABS, because I think ABS is the right material for doing this kind of stuff. Absolutely, without a doubt, should be ABS. I mean, especially this stuff here. All that stuff that's close to the hot end, 100% should be ABS. Presumably there are environmental factors that they have to account for as a company, so maybe ABS not so happy that side, or they have problems with toxic fumes because they've got a farm of 200 printers, or however many printers they have, probably more than that. Then that's going to be a lot of fumes that they don't want to deal with, so PETG, less toxic, less problems, less filtering required. Just notice we're up to a solid 16 likes. That's pretty good. Pretty happy with that. If anyone hasn't liked, I'm just going to keep endorsing myself, seeing as it's... I mean, I'm not doing a lot, so really you're liking the printer rather than me or the channel, because the printer's doing all the work. But if you want to leave a like, that would be muchos appreciated. Seeing as some of my videos, even when they're like 2 minutes long and have nothing controversial in them at all, people just dislike them, and I really don't understand why. But there we go. That's a topic for another time. We're 80% complete, 42 minutes in. It does quite do a really... Words, come on, construct the words properly. It does do a quite big jump when it does the... when it does retraction and movement to a new point. But then because they've got these, so these threaded rods, I believe, are the same as the Mark II. So they have a, or maybe they're not. Maybe that's why the G-code didn't work. I'm pretty sure they are. They look like it. Yeah. So they're 4-start, 2mm pitch, 8mm lead. So a single rotation of the stepper motor will get you 8mm in height, which means they can move up and down pretty quickly. As long as you've got sufficient torque in the stepper motors, which, I mean, they got two stepper motors for something that weighs a few hundred grams. They're going to have no problems with torque, which is obviously why they've got such small stepper motors. You just didn't, they barely need two. The only reason for two is for the balance. So it's just done the bridge, which looks pretty good. Can't be far away now. Still nice and cold. Still nice and quiet. I was expecting potentially it got louder as it got towards the end of the print. On, I don't know, for whatever reason, it might get louder over time as the fans speed up. But no, it's pretty cool. Pretty cool, pretty chill. Almost as chill as me, sitting here doing a whole lot of not very much. Oh, I got an email notification to let me know that CRT is live. I'd better go watch that. It has slowed down a lot while it's doing this narrow part at the top. It's obviously hitting those minimum layer times and slowing down to prevent the sort of thermal runaway. It's not really a thermal runaway, but the excessive heat build-up in the part. Where did you buy the lead screws and smooth rods of your Mark II clone? I think I got them from AliExpress. I was gonna. Yeah, I'm pretty sure I got mine from AliExpress. Nowhere special. I didn't use. So Obio Printing do integrated units like this, but to get a kit for a Prusa is €90 or something, which is not really my cup of tea. It was a bit expensive, so I went for external ones. So you can get stepper motors, OMC online for very little money. Smooth rods, you want, I think the best ones to get are the hardened and chrome plated, or at least get hardened. You don't want standard stainless steel as far as I'm aware, because it's softer than hardened mild steel. To buy local for, well, I don't think so, but as far as I'm aware, anyone that has lead screws around the cost that we're looking for, around the cost of the Chinese ones, all come from China anyway. So anything you'd buy locally will have just been imported from China, so you're basically just spending more money on the same thing. If you wanted to buy proper lead screws, as in commercial, industrial quality ones, then you're going to be spending a whole lot more money anyway. If you went to IGUS or to Motion, what is their company? What's it called? LinearComponents.com or something. But there's hundreds of pounds each or something crazy. So in my mind, might as well get them from China. As long as they come in straight. I bought, if you want 2x3, for example, is a little bit, does make it a bit more expensive. You can risk it and just get 2, but I'd much rather get 3, and then I can pick the best 2 out of those. And plus, the more you buy at once, they sort of bundle them together, and it makes it stiffer, so less easy to bend. The last few I've had have been quite well packaged as well. Either a thick cardboard tube or PVC pipe, which seems to help. I'm not sure. I mean, it seems weird to protect 8mm steel with a piece of plastic or a piece of cardboard, but if they're delivered flat, they're delivered flat, straight. So don't care how they get here, as long as they come straight. I am getting, so the nuts that I had, the graphite nuts, I've got some more of those on the way. Not a lot of them, because I didn't expect them to really be very expensive. That's not what I meant to say. I'm not getting a lot of them because I didn't expect many people to want to buy them, because they are fairly expensive. That's what I was going to say. So I've got a few sets of those that I'll probably just sell on eBay, but I'll link to my YouTube video just to say that they're for sale if anyone wants those. Will Prusa publish step files of the Mk3? I can almost guarantee you that they won't. Based on the information that I was able to get for my printer, I'm pretty sure that's not going to be happening. They are, well, this might sound all controversial and whatever, but I think Prusa are not as open as they claim to be. I've tried, when I was making my Prusa clone, half the point of it was to see how open they were, how much information they will provide, and it should be, for an open source company, it should be pretty much everything. If you want to know, for example, the extruder springs on the Mk2, they don't tell you what size they are, what the dimensions are, what the spring rate is, and if you ask, they go, oh, we can't support you. It's like, well, I want to build a printer. I want to build a Mk2. And it's open source, so all this stuff should be available. And they just sort of say, oh, I'm afraid we can't help you. It's like, well, they didn't just appear out of thin air. You must have known what you were buying, because you've got to buy thousands of them. And I, don't get a lot of information back, so I don't think they don't want people, obviously, to be able to build their printers. Their open source basically boils down to distribution of the STL files, which are pretty basic and anyone can cobble together anyway. That's the least of your problems when trying to build a 3D printer. But there you go, that's just me. Yeah, it slowed right down now. It's doing the nozzle, the chimney, whatever the, you know, the spouty bit on top. We're getting closer, we're getting closer. 93% complete. It's got to be more than that. It's basically there. I can see some small amounts of stringing, but I'll give you a nice close look when it's done. La, da, 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 da. It's getting exciting, so close. That chimney is so freaking tall. Oh, no, it hasn't taken anywhere like that amount. It's probably not quite clear enough. 51 minutes. The only reason the stream's taken so blooming long is because I did this one first and that failed, and then I did this one and that failed. Well, both times because I pulled the power out and it didn't recover. Well, and there we go. Right. I'm going to bring this camera in so you can get a good look for yourself. Well, I will if I can get the cable to. It's not going to. Come on, focus, please. Doesn't want to focus. It's because of this weird metal plate. It doesn't like it. It doesn't like that either. This is only 80% scale, by the way. Move it to white paper. Ah, oh, damn it, that's got two sides. Ah. How about this? It's a coffee filter, which I use for isopropyl alcohol, but it seems to have wanted to focus on that a bit better. How's that vision now? It looks like it's focused. Focused. It looks pretty good. I mean, there's definitely... It's weird how there's sort of... You can see clear lines in it where, like, the temperature's changed or the speed changed or that sort of thing. I think that's as a result of it being quite a glossy filament. Those sorts of things stand out a bit more. Overhangs are good. The cooling around the top looks pretty impeccable. No signs of dodginess there. The chimney at the top's pretty good, so that's done well. I mean, it's PLA, so it's pretty easy to print anyway. The extrusion amount, probably slightly over, I reckon. The top layers look reasonably good. The top layers in halfway down look a lot better than the top layers right at the top. The bottom, reasonably good. Quite difficult to see because it's so shiny and there's a lot of detail on that bottom where it writes the word. Back is maybe less good. There's some funny little details wrong here. There you can see. Can I get this in the light a little bit better? Is it gonna focus, please? Focus, please. Here, this line across the bottom. Yeah, it was very quiet, so you can definitely get that. The bed cools down ridiculously quick. Because it's only PCB material, there's no metal in it. No metal in it, no metallic, no aluminium, no steel, apart from obviously the steel top. It has no heat capacity, thermal latent heat capacity. So the amount of thermal energy it stores is very low. So, I mean, as soon as you turn the temperature off, the heater off, that's it, it's back at normal temperature. In fact, the frame below it is almost as warm as the print bed. I think that print quality is pretty good. Oh, there's a bit of a... So as I was saying, I don't know if you remember me saying at the start, but there was definitely some over extrusion. I think as a result of those having so many thick bottom solid layers, which again what makes me think that it's slightly over extruding. So because it had that curl up, you've got some weird artifacting along the front there. The overhangs are good though, the bridging rather. There's no major droop on the bridge, on the roof. Cooling's obviously pretty consistent all around. These edges are really sharp. Pretty good, pretty good, pretty good, good. Right. So, what's next then? I guess we should try, I'm not going to do an entire new print, but I will start one so we can, oh god, those, the springs are way too strong. I don't mean springs. The things, you know, the metal things, magnets, that's the one. Okay, so did you calibrate the thermo things? No, it said it was optional and I couldn't be bothered, quite honestly. I don't think it's going to make much difference because the problems I had I don't think were thermal related. I'm pretty confident that the temperatures were what they said they were because they did match what I expected my room temperatures to be at the start. So let's go. I'm just going to start another one of these. We'll let it get a couple of layers in and we'll cut the filament and see that working, hopefully, and not jamming, hopefully. Given the results that we've had so far, we can't be too sure. Just got to wait ages for it to heat up. It's nice that it heats both at the same time. Quite often you get one heat, the bed heat, and then the nozzle heat, which I've never understood. Whoopsie daisy. See, this is exactly the same print. Exactly the same G-code, done one immediately after the other. Look how different that front is there compared to that one. You'd think they're completely different G-code. I don't understand how they're so different. It is unbelievably quiet. Look at all this splodgy mess though it leaves. Is Tom's hang printer still, live stream still going? Let's get some of this horrible gunk off here. Well, we need to do the skipped step thing as well. So I think there's the last two features we need to test. Cut the filament and jam the stepper motor. I wonder if it works for the bed as well. I mean, it definitely works for the extruder, but presumably it worked for the bed as well. It must do. It's so good. It does still have that weird new smell. There you go, that's stealth mode. It wasn't even on quiet mode before. Okay, now it's doing some fucking crazy shit, but... Let's get this at a point where you can see. Okay, it's showing like 55 on average, but it is doing some pretty insane maneuvers with some pretty ridiculous acceleration, which... I can hear, as soon as I turned stealth on, I could hear it was quieter. So I can tell you there's a difference. But it's clearly not showing it in this meter. Yeah, it's noticeably different. I don't know what it's changing when it does that, because obviously the speed seems to stay the same. So, don't know, but there you go. That's what's that. Yeah, I suppose it is. Oh, yeah, you can tell that they seem to be finishing because I've just shot up to 30 people. So there should be 10 new people here. Hello to new people that have just probably come from Tom's stream. I'm just about to cut the filament. In fact, let's do... How is the print quality? Oh, the print quality is back to the good first one. So if we just... There you go. Interestingly, it didn't actually, because obviously I can feel it, it didn't actually skip the step. It didn't do the skip. I just had to apply enough force for it to realise that it was pushing against something, and it's like, oh, that's... Presumably it thinks it's an end stop. It's the same sort of sensing or something. It just immediately reset. So let's try y-axis. Yep. They do push pretty hard. Don't test skip step in silent mode. Why don't you test, does it not work in silent mode? What's going on with that then? Why would I not test it in silent mode? I do quite like doing it though. Yeah, I put it back on normal. I don't know why I did. I've got no particular reason. It's off by design. Interesting. Presumably, I don't know. I don't know enough about it to know, but presumably that's one of the features that results in slightly more noise. It would skip easily in stealth mode. To be honest, I think we might as well try it. We might as well do it, and then we can find out for ourselves what happens. So what if it ruins the print? This is not designed to be a finished print. Let's do the skipped. Oops, dear. Let's do this first. Oh. Gotcha. It wasn't in silent mode before. It's been in normal mode the whole time. I just turned it to silent quickly for that one test, and now it's back on normal. Oh, that's the filament gone. I'm just going to laugh so much if it just carries on and just doesn't realise. I'm pretty sure it's carried on and not realised. It's been printing for ages. I think it hasn't worked. Oh no. Wow, that went for a long time. Press the knob to unload the filament. Unloading the filament. I'll just leave it, see what it does. God, it's pushing a whole load of filament out the bottom, Jesus. It's still going. What is it doing? It's like it's purging an entire new colour. Yeah, you have to take that off, otherwise it's just going to spurge. Yeah, so you have to be able to remove that, otherwise it's just going to... That's pretty cool, that it's just carried on. And now I've ended up with this nice little spring. It's like a Christmas tree. Yay! So perfect. So this print still looks basically perfect. You can just do whoop. It's so good. Oopsie, skipped a step. Carry on. That is absolutely brilliant. I don't think I'll ever get bored of that. I'll just come in like the middle of 5-hour prints and just push it just to show it I'm still in control. So you can, well, you probably can't see from there, but I can see down on this front wall of the print where it's done those skip step things. There is a bit of a blotch. It's not perfectly smooth like it was on the side of this, but for goodness sake, it's what would have completely corrupted an entire print before, and now all you're left with is a tiny little blob. So that's pretty epic. Next we're going to do switch back to stealth mode. So go back in mode. So crash detection is on at the moment. I switch this to stealth. So that menu item disappears when you put it in stealth mode. So in stealth mode there is no crash detection. So I think as soon as I try and nudge it now, it's just going to fail the print. It'll stop, or it'll just continue printing slightly differently. Well, if it succeeded this, I would do the power thing, because I'm trying to make this print fail. And I've got until the end of the print. So, I mean, it's 9:30. It's still got 50 minutes to go. I'm probably not going to wait till the end of the print. But hopefully, if I now... Yeah, so it skipped a step there, and I felt it do it, and it didn't correct anything. So now you probably can't see from where you are, but I can see it. That layer is now. Yeah, this silent mode skip test is 100% failed, which is fine. That's the difference. That's what you get in silent mode. So when the extruder moves up, oh, it's not going to move. It's going to be ages over here now. Don't know if you can see yet. I'm trying to show you that it's... Well, you'll just have to take my word for it. So that layer that it's doing now is offset from the previous one by about 1 millimeter. It's all just squiff. So let's put it back. Tune, mode stealth, mode normal, and then you could turn crash detection off if you're a crazy person, but I can't see why you would do that. In fact, let's turn it off and see if it changes the volume. Yeah, so I think if you look in the printing profile, it does the maximum speed that it says. So what was it? Speed. In the speed profile, the speed that they set in the profile for infill and solid infill is 200 millimeters a second, but that is maximum speed. So, I mean, there's no guarantee that you'll actually reach it. So turning off crash detection didn't seem to make much of a difference there. Let's get that back on. We could try, let's crank the speed. So that's 120%. 140%, 139. Despite the fact it did a skipped step, this print still looks pretty good. Obviously, apart from that shifted layer, it's recovered. It's not all gone droopy as a result. I mean, it's not. I don't think I can really show that much by just pushing this up really high. Okay, it's going pretty ridiculous now. That print speed is insane. I almost need a higher refresh rate video to actually be able to show you. Oh, that's a good point. Okay, so yes, now that it's turned it on, let's do a crash test. Let's see if that now goes back to the original position that it should have been at. I think it has. Yeah, so that has now... So we've now got a step in and a step back out. So where we went to silent mode and made it skip a step, it went all out of position. And when we've turned it back on, we've nudged it, it's gone back into position. So if you were doing a long stealth print and you'd noticed that you'd had an offset and you'd only done a couple of layers, you could switch it back on to normal mode, give it a nudge, force it to reset, and then it would carry on back in the correct position. That is ridiculous. And this is printing at 200% speed. It still looks ridiculously good, to be honest. Considering at this point how many failures this one single print has had, and it's about to have another one. This is so fun. There needs to be a game. Try and crash the printer game. Bye bye filament. Bye bye. Bye bye. Now we just have to wait and see. That was a good call on seeing if it resets. Yeah, it's... Oh, it's attached to this piece. It's not fully... Let's hope it doesn't jam. One thing I do remember Joseph saying at TCT 2017 was that you don't have to press the knob to make it do the filament loading. He said you just put it in and it senses that it's there and it does the filament load. But that doesn't seem to have happened. So I don't know quite what's going on with that. Ooh. We got ourselves more of a blob than a Christmas tree this time. It's not quite so pretty. Okay, I really need to join this group for getting all these things that Joseph seems to say in the Prusa group. Is it a Facebook group? It seems to be that I need to join. I miss out a lot on this, a lot of these things like the PTG, the brown fans coming with the early versions, what's upcoming in the firmwares and things like that. Yeah, that'd be cool. So if it came, what it should do, hopefully, in the new print and in the new version is you cut the filament, it goes in, it detects it's not there, comes to the side, immediately ejects it, you take it out, push the new one in, it notices it, loads it and carries on. That's absolutely insane. It looks ridiculous where it's just skipped a step, gone completely to the wrong place, and then just recovered entirely. Absolutely insane. When you order a Mark III that would ship in February, you end up watching everything he says on YouTube until February. Yeah, I sort of partly didn't want to know... No, that's not entirely true. I was trying to find everything I could. Because sometimes when I get new things, I don't want to know about them until I get them, and then I discover what it has, and then take a look elsewhere for other information. I've just got to try and show you this. Can you see the front of that benchy? You can't really, it's too dark, isn't it? You can see how it steps out and then steps back in again. Because of where I did the stealth, the skip, and then back to normal, and then another skip. Stop both X and Y at one time. I don't know if that's going to be possible. I'm pretty sure that won't work. I mean, this is now locked, so as soon as you do one, it locks them both still. It can't lose. What do you mean by watch your hands? Did I almost... I've just got to do this again. It's at 200%. Let's go up to 300%. It's worth noting that it's still keeping at speed. Safety is for weaklings. So we're now at 300%. It's still maintaining the temperature, so that it is starting to go a little bit. It's quite a lot louder now, actually. But probably it's probably still quieter than a normal. I don't think they can smash your hands because that's. I mean, because that is the crash detection. That's what's happening when it. I don't know. I'm being pretty careful. I'm careful enough, I think. This still looks pretty good. How many times have I tried to crash this? Okay, so if I try and stop one of the fans. No, so it doesn't seem to detect that at all. I purchased as a kit, Kerry. I've just, over the last 2 days, I've spent 9.5 hours building the damn thing. If you go look at my channel, there's 2 other streams from the last 2 days that are archived. You can watch those. Well, you can't watch them all right now because obviously it takes 9.5 hours to do so, but yeah, you can go watch those. It's been quite a good bunch of streams. I mean, what else can I do? This. So I think you can. I don't think it seems to work for the Z-axis. Okay, so I did it for the Z, so now it's not horizontal. So is it going to home up to the top? No. I guess that's that gone then. And there we go. We killed it. We properly killed it. That's how you destroy a print on a Prusa. You have to jam the Z-axis. It's the only way. Okay, and the power loss thing. The power. I love how many times we've tried to crash this one print. Let's take a... Whoa, that's satisfying. Right, let's come and take a closer look at this print. So, bear in mind, I've tried to crash this print probably upwards of 6, 7 times. Cutting the filament a couple of times, jamming the X-axis several times. Turning to stealth mode, getting those skip steps so you can see how many layers we did there. This front portion that's offset, that was all because of skip steps, which is then completely reset back to the perfect position after going back to normal mode and then crashing it again. It's still pretty smooth, there's no massive problems, apart from the obvious things. Some hot spots, some extra filament where after the filament failure you've got some extra bits sticking out. But I mean, damn, if you did any of these things once to a normal printer, it would have absolutely, it would have just died first time. But yeah, it's the Z-axis that will get you. So we now need to calibrate the Z-axis, because it needs to level these axes out again, because I pushed this one down pretty hard. Let's hope it doesn't jam into the bed, please. Yeah, it's going to go up first. I know. Oh, it's just... Okay. It's now trying to calibrate itself while completely wonky. It's a long way off being level. I shouldn't have done that. I need to get that Z back up to the top. Surely the calibrate Z, first thing it needs to do is go up to this one's all squeaky now. So in summary, I don't think there's going to be a lot left to look at. Oh, by the way, this printed at flipping 300% speed. I forgot about that. Look at that! 300% was probably these layers up here. Most of it was at 200% speed. That is ridiculous. Ridiculous. The speed that it did it as well. That's unbelievable. It's just like a game. Yeah, so now it's going to do that level the Z-axis thing. So hopefully you'll be able to see if I put the thing up there. It should hit this side first and then it'll do this side, because I pushed that side down. Okay. Okay. I just realised something. I always thought that it was the nuts hitting on this part here in this area that did the Z calibration. It's not this main body hitting on these screws. So I'm just going to do this again now that I know that I've fecked it multiple times. Can I do a vase? I'm not going to do any more now because it's 10 o'clock. I'm just going to... This really needs some oil on. I will try and do a high-speed vase mode at some point. Yeah, it would be quite cool to see a vase literally make itself in like 5 minutes. I'm not sure it'll be possible, but it'd be quite cool to see if it could. I mean, I'd probably do 0 bottom layers, so it wouldn't be a vase, it would just be an outside, because otherwise just the base layer takes like 90% of the print time. Stepper motor warmth is not too bad as well, and they're probably slightly warmer than my skin, so maybe 40 degrees or something, but I mean they're not hot at all. This does take forever. I guess you guys probably don't really want to watch this, so I think it might be about that time again to call it a day, unless anyone has any more questions about what we've done up to this point. Don't forget to leave a like if you've enjoyed it. That would be much appreciated. I mean, I think you should leave a like just based on the fact that we managed to do this, trying to crash the printer in 10 different ways, and it still flipping succeeds until I jam the Z-axis. So yeah, thanks all for coming. Thanks for sticking around. And I guess, I mean, I don't know when my next stream's going to be at this point. I've spent a lot of time doing this week, so... Someone's just left a dislike. Oh man, come on. We were doing so well. 19 likes, and now we've got a dislike. Anyway, yep. It's been good fun. I've enjoyed myself. Hopefully we've all learned a little bit about this printer and its capabilities, and the fact that the power supply thingy doesn't particularly work that well at the moment. But that being said, I'm pretty happy with it so far. Hopefully a full review will be coming on the way at some point. As I said, Team Brown Fan, absolutely. Brown Fan team, maximum points for Brown Fan team. And I shall see you, well, goodbye, and I shall see you in the next one. Yes, they changed it back to a like. Come on, 22 likes. Cool. Thanks, everyone. Goodbye.